For millennia, humanity has gazed up at the night sky, mesmerized by the twinkling tapestry of stars. We've spun tales of constellations and charted the courses of planets, but it's only recently that we've begun to grasp the profound connection between ourselves and the cosmos. The truth, as we're discovering, is far more wondrous than any myth. We are, each and every one of us, made from stardust. The atoms that form our bodies, the iron in our blood, the calcium in our bones, all were forged in the hearts of distant stars, billions of years ago. Join us now, as we journey to the edge of the universe and back, to explore the incredible story of Stardust and the cosmic origins of life on Earth. Picture, if you will, a single grain of sand. Now imagine that grain, smaller than the width of a human hair, adrift in the vastness of space. This is stardust. These microscopic particles, often composed of elements like carbon, silicon, and iron, are the remnants of ancient stars, born from their fiery deaths and scattered across the cosmos. They are the leftover building materials of the universe, cosmic debris that carries within it the potential for life itself. Some are flung out into the interstellar medium during the violent deaths of massive stars, supernovae that outshine entire galaxies for a brief, brilliant moment. Others are formed in the gentler but no less awe-inspiring death throes of smaller stars like our Sun, as they shed their outer layers into space. Still, other dust particles are born from the collisions of asteroids and comets, celestial wanderers that carry within them the preserved history of our solar system's formation. These collisions, though destructive, release a shower of stardust into space, seeding the universe with the potential for new beginnings. While individual dust grains are incredibly small, their sheer abundance across the vastness of space means that they play a crucial role in the evolution of galaxies and the formation of stars and planets. They are the seeds from which entire worlds are born, the raw materials from which life itself may arise. As we delve deeper into the mysteries of Stardust, we begin to uncover the secrets of our own origins, tracing our lineage back through time and space to the very birth of the universe itself. Imagine the early solar system billions of years ago. It wasn't the relatively peaceful place we know today. Instead, it was a chaotic and violent arena, a cosmic shooting gallery with the young Earth squarely in the crosshairs. Our planet, still in its infancy, was bombarded by a relentless hailstorm of asteroids, comets, and interstellar dust particles. These celestial wanderers, drawn in by the pull of gravity, crashed into the Earth's surface with incredible force, delivering not just destruction but also the key ingredients for life. Scientists believe that meteorites, those chunks of space rock that survived the fiery plunge through our atmosphere, played a crucial role in this cosmic delivery service. Locked within their rocky interiors were essential elements like carbon, hydrogen, nitrogen, and oxygen, the fundamental building blocks of life as we know it. But it wasn't just about the raw materials. These celestial messengers also carried within them something even more precious: water. Comets, those icy remnants from the outer reaches of the solar system, are believed to have delivered vast quantities of water to the early Earth, filling our oceans and setting the stage for life to emerge. The idea that life on Earth could have originated from space, seeded by stardust carried on the backs of comets and meteorites, is a profound one. It speaks to the interconnectedness of the cosmos, the notion that we are not isolated islands in the vastness of space but rather part of a grand, interconnected web of cosmic evolution. Consider your hand for a moment. The flesh, the bone, the intricate network of veins and nerves. It seems solid, permanent, uniquely you, yet we now know that every atom within that hand, every element that makes up your being, was once stardust, forged in the fiery hearts of stars long gone. Think about it. The carbon in your DNA, the very blueprint of life, was once part of a giant star, a sun perhaps much larger and brighter than our own, that lived and died billions of years ago. The oxygen you breathe, the nitrogen in your muscles, the calcium in your bones, all were created through a process called stellar nucleosynthesis, the cosmic alchemy that takes place within the cores of stars. Massive stars, much larger than our sun, act as cosmic furnaces, fusing lighter elements into heavier ones through nuclear fusion. These stellar giants create elements like oxygen, nitrogen, and even iron, the element that gives our blood its characteristic red color. When stars like our sun reach the end of their lives, they shed their outer layers into space, enriching the interstellar medium with elements like carbon, nitrogen, and oxygen. These elements, scattered across the cosmos by stellar winds and supernova explosions, mix with interstellar dust, forming vast clouds of gas and dust. These clouds, in turn, become the birthplaces of new stars and planetary systems, continuing the cycle of cosmic creation. The famous astronomer Carl Sagan once said, "We are made of star stuff." And indeed, science has shown us just how right he was. If the ingredients for life are scattered throughout the cosmos, if those very building blocks were delivered to Earth billions of years ago, a truly profound question arises. Could life, in some form, exist elsewhere in the universe? It's a question that has captivated humanity for centuries, fueling countless science fiction stories and scientific inquiries. And now, armed with the knowledge of stardust and its role in the origins of life, we are beginning to see that the answer might very well be yes. Consider this. Scientists have discovered organic molecules, the building blocks of life as we know it, in the most unexpected of places. Amino acids, those crucial components of proteins, have been found in meteorites, suggesting that they are not unique to Earth, but rather common throughout the cosmos. Sugar molecules, essential for energy storage and DNA structure, have been detected in interstellar clouds, those vast nurseries of stars and planets. And on Mars, our closest planetary neighbor, scientists have found complex carbon compounds, hinting at the possibility of past or even present life. These discoveries, while not definitive proof of extraterrestrial life, are nonetheless incredibly exciting. They suggest that the ingredients for life are not unique to Earth but rather scattered throughout the universe, waiting for the right conditions to come together. If stardust could seed life on our planet, then it stands to reason that it could do the same on countless other worlds. The discovery of even the simplest life form on another world would be a profound moment in human history, forever changing our understanding of our place in the cosmos. The quest to understand our cosmic origins, to unravel the mysteries of stardust and its role in the origins of life, is one of the most profound scientific endeavors of our time. NASA and other space agencies around the world are actively studying cosmic dust, sending spacecraft on daring missions to collect samples and beam back data that is revolutionizing our understanding of the cosmos. One such mission was the aptly named Stardust mission, which launched in 1999 and traveled billions of miles to collect dust particles from a comet's tail. This precious cargo, returned to Earth in 2006, provided scientists with an unprecedented glimpse into the composition of comets and the early solar system. Meanwhile on Mars, the Perseverance rover is busy exploring the Jezero crater, a location believed to have once been a lake billions of years ago. Perseverance is searching for signs of ancient life and collecting rock and soil samples that will be returned to Earth for further analysis. And then there's the James Webb Space Telescope, the most powerful space telescope ever built, which is currently orbiting the Sun 1,000,000 miles from Earth. With its unparalleled sensitivity and resolution, the James Webb Space Telescope is peering deep into the cosmos, observing the birth of stars and galaxies, and studying the atmospheres of exoplanets, planets orbiting other stars. These missions, along with countless others, are providing us with a wealth of data about the universe and our place within it. Every new discovery, every piece of data collected, brings us closer to understanding our cosmic origins and the incredible journey that led from stardust to life on Earth. The search for stardust is, in many ways, a search for ourselves. From the smallest grain of sand to the largest star, the universe is connected in ways we are only beginning to comprehend. Life on Earth, in all its diversity and splendor, may have begun with cosmic dust, making all living beings part of the universe itself. The elements that make up our bodies, the very air we breathe, came from stars that lived and died long ago. Their fiery deaths scattered the building blocks of life across the cosmos, eventually finding their way to a young, developing Earth. And even now, space continues to shape our world. Comets and asteroids, remnants of the early solar system, still rain down on our planet, reminding us of our cosmic connection. The next time you look at the night sky, remember, you are looking at the very stars that made you. You are a part of this grand cosmic story, a product of billions of years of stellar evolution.